All right, we are now about to officially enter into trigonometry. All right, here we go. Purpose of this video, to know and use the definitions of the 6 trigonometric functions. Review. You might not remember it, which is fine, but in geometry, you actually learn these definitions of the trigonometric function. So in terms of a triangle, so we're going to actually review that first, kind of lay the groundwork, and then make a leap into the pre-calculus stuff, which is what does sine, cosine, tangent have to do with a unit circle and the angle stuff we've been doing in radians, and how does this all connect? We're going to make that what the state of Georgia and most, the standards, because it's Common Core, make an extension. How can we take those trigonometric functions that you've learned before and connect them to what's called a unit circle in the coordinate plane, radian measures, real numbers? So this standard is going to take a while to unpack, and we're going to start it right now with this video. So this is not everything. This is just a little bit, roll out a little bit more, roll out a little bit more, and then this standard will make sense. All right, so let's get back into the stuff from geometry. Sine, cosine, tangent. So just to remind you, when you see this, don't say sin. It's a pet peeve. It's the sine function. It's just an abbreviation for the sine function. It's on your calculator. And you would read this sine of theta, all right? But the actual name of the function is sine, S-I-N-E. You have the cosine function, and the abbreviation for that is COS. So you have cosine of theta, and then you have the tangent function, which has an abbreviation TAN, and you would say tangent of theta. And when I say of, it's literally just like a function note. It's function notation. F of x. This doesn't mean multiplication, just like this doesn't mean multiplication. This means the name of the function is f, and x is the input. You plug a number in, you get a number out. So for the sine function and the cosine function and the tangent function, you plug in an angle measurement and you get a number out, and that number that comes out is a ratio or a decimal or just a number. It's just a value. So you plug in an angle, you get out a value, and we're going to start kind of conceptualizing that today in greater detail than in the past. Okay, so those were the original 3 from last year, old stuff, sine, cosine, tangent. But each function has what's called a cofunction. So sine has a cofunction, cosine. Tangent has a cofunction called cotangent. And then secant and cosecant, okay? So cotangent has an abbreviation COT. So that's cotangent of theta. Secant, SEC. Hey, I'm a Georgia fan. My wife and I met at UGA. Math majors. Woo, woo, go dogs. Okay, so SEC. And then you have cosecant, and the abbreviation for that is CSC. So that one's a little weird. Cosecant. All right, so that one's a little strange. The others are just first 3 letters, first 3 letters, first 3 letters, first 3 letters, and then you have skirt. It's just weird. Cosecant. Okay, so those are the names of the functions, not the definitions, just the names. This is notation, so this is the way you write it. And it might be sine of theta, it might be sine of x, it might be sine of t, sine of alpha, it could be whatever. Lots of different symbols, but SIN means the sine function, and then whatever symbol you put beside that is the input of the function. Okay, so let's define them using the same definition from geometry. So we're going to use the right triangle definitions at first, and then we're going to build on that to build an actual function that is defined for all real numbers, which for now, the input is theta, and this angle, if we're talking about a right triangle, this angle can't be more than 90. So right now, the first definition is a little limited, but that's all right. So if we're talking about the base angle of theta, this angle here, then for a right triangle, you always have leg 1, which is opposite the angle, leg 2, which is adjacent. Adjacent means side by side, like Alabama is adjacent to Georgia. Alabama, y'all. I lived in Alabama until I was 7. I was born in Alaska. It's kind of crazy. My dad was in the Army. Okay, so you have 2 legs that build a right triangle, right? They make 90 degrees. The adjacent leg to the angle and the opposite of the angle. So you have opposite leg, adjacent leg, and then of course the hypotenuse is always the longest side of a right triangle. So this is definition. Sine of theta will always be the opposite leg over the hypotenuse. Just straight definition. So sine of theta equals opposite over hypotenuse. Okay, so like a mnemonic device, I'm going to give you a way to memorize this in just a minute. Then you have cosine of theta, and cosine of theta by definition is the adjacent leg over the hypotenuse. So once again, these are just basic straight definitions. This is how the original trig functions are defined, and then we expand on it. So cosine of theta is the adjacent over the hypotenuse. We're going to see how to use that. Tangent of theta. Tangent of theta is opposite over adjacent. The most useful of the 3 because in general the legs are easy to find. It's easy to find a horizontal length. It's easy to find a vertical length. So you'll use tangent when actually solving problems more than any other function, even in calculus. Okay, so here's the mnemonic device I was talking about. And my hope is you've heard this before or seen this before, but if you haven't, it's a big deal. If you want to memorize the trig functions, that's what you want to memorize. SOHCAHTOA. That's it. Sine is opposite over hypotenuse. The sine function of an angle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The tangent of an angle is opposite over adjacent. So this helps you memorize the first 3. Okay? And then the other 3 are literally the reciprocal functions. And we're going to use that fact a lot. So tangent and cotangent are literally reciprocals. So since tangent of theta is opposite over adjacent, cotangent of theta is just adjacent over opposite. You literally take whatever the output is and you find the reciprocal. Okay. Cosine and secant. So cosine, you want to memorize this now. At some point, you want to memorize these definitions. Cosine and secant are reciprocals. So secant of theta is by definition 1 over cosine of theta, which means the reciprocal of cosine. So all you have to do is take the output, adjacent over hypotenuse, and change it to hypotenuse over adjacent. Literally flip the output. That's the definition. Okay? And then that takes us to cosecant. Cosecant and sine are reciprocals. So cosecant of theta is 1 over sine of theta, which means it's the reciprocal. And since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So you have to memorize. Cotangent doesn't exist in my vocabulary in terms of like a language. I think cotangent, I think find tangent and flip it. That's it. Simple. Secant doesn't exist. Find cosine. Flip it. Cosecant doesn't exist. Find sine and flip it. So these 3 that I'm putting bubbles around really only exist in terms of the other three. Okay, so you really want to memorize how do you find sine, cosine, and tangent, SOHCAHTOA, and you'll practice this. How do I find cotangent, secant, and cosecant? Well, I have to know cotangent is the reciprocal of tangent, secant is the reciprocal of cosine, cosecant is the reciprocal of sine. Okay, so all of that is just stuff you're going to use over and over. You'll commit it to memory, you'll forget it, you'll recommit it to memory, and so on. And at some point, you'll just remember it. Okay, let's do one example. Once again, this is kind of old stuff. Everything we've done so far, geometry, and we're about to get into the new stuff. But we have to review the old stuff before the new stuff will make sense. So, given a right triangle, this was a standard geometry problem. If you're given two sides in a right triangle, of course you can find the third side. So that would be, I'm going to call it B. In general, the legs are A and B. A is the shorter leg. All right, that definitely appears to be shorter than AC, which is, I'm going to call B. And then my hypotenuse is 5. So I just want to remind you, Pythagorean theorem says, if we have a right triangle, then leg squared plus leg squared equals hypotenuse squared. So 2 squared plus b squared equals 5 squared. So my hope is you're like, I remember that from 7th grade, 6th grade, 8th grade. You solved this over and over way back when. Big deal in middle school. So 2 squared is 4. 5 squared, 25. Subtract 4 on both sides of this equation. So b squared equals 21. So b is the square root of 21. And let me say this now. Leave the square root of 21 as the square root of 21. We are concerned with exact values. You don't want to approximate it, because then you're going to use that approximate value. Then you're approximating again and so on. Every time you approximate, you lose some accuracy. So leave that radical 21 or square root of 21, leave root 21 alone, and just know that when you have 3 sides of a right triangle, the vast majority of the time, one of those will be an irrational number, meaning a square root that cannot be reduced, cannot be simplified into a whole number or an integer or some fraction. Okay? All right. So, sine of A. So A is this angle. So we have 2, which for angle A, now I'm only talking about angle A, not angle B. That would be a different thing. Angle A has an opposite leg. A has an opposite leg over here. It has an adjacent leg here. And it has the hypotenuse. Sine, so remember, SOHCAHTOA, right? Sine, cosine, tangent, SOHCAHTOA. To this day, that's how I remember sine. Sine is the opposite over the hypotenuse, so sine is 2 over 5. SAT prep, big time on the SAT. Now, sine and cosecant, they are reciprocals. So if sine of an angle, if sine of A is 2 over 5, then cosecant of A is 5 over 2. Easy peasy. If you know sine, you can find cosecant. If you're looking for cosecant, find sine and flip it. Okay, so that takes us to cosine. Cosine is the adjacent leg over the hypotenuse. Cosine is adjacent over hypotenuse. The adjacent is root 21, so we get root 21 over 5. So cosine is root 21 over 5. Well, cosine and secant are reciprocals. So that means that secant is 5 over root 21. But, going way back, I cannot have a fraction with a square root in the denominator. So we have to rationalize the denominator. Now, with technology today, it's really not a big deal to leave it 5 over square root of 21, and some of your college professors do not care. You can leave it 5 over root 21. But if we're trying to manipulate fractions, it's much easier to deal with an integer or a whole number than it is the square root of 21. You know, when you're adding or subtracting fractions, common denominators are necessary. You don't want root 21, okay? So before the calculators were so common, this was no good. So here's what you do to deal with it. Okay, so you take 5 over root 21, and you simply multiply top and bottom by the value in the denominator. And here's why that works. First of all, you're multiplying by 1. Any number over itself, any number divided by itself is just 1. So you're taking this fraction, which is not considered simplified, and you are multiplying by 1. You're not changing the value of it. What's 5 times 1? It's just 5. What's any number times 1? It's the same number that you started with. It's just going to look different. It's going to be in a different form. 5 times the square root of 21 is just that, over the square root of 21 times the square root of 21 is 21. We now have a denominator that is a rational number. Rational, believe it or not, the Greeks, square root of 21 is irrational. It is a decimal that never ends and never repeats, and it goes on forever. The Greeks denied the existence of irrational numbers. It's crazy to think that 3,000 years ago, if you talked about rational functions or irrational values in some places in Greece, they would actually kill you. It's crazy. We kill people for different reasons now. It's a whole other conversation. Very sad. Okay. So 5 over the square root of 21. We multiply top and bottom by the square root of 21, and we get the final answer, which is in reduced form. It's considered simplified. Even though it looks more complex, and it is, there are more values involved, it's considered simplified. So I want you guys to see this pattern that you're going to use over and over if you have not already seen this pattern. Every time you have a number over a radical, so an integer over the square root of an integer, all right, whole number over square root of whole number, you're always going to multiply top and bottom by the square root of b in this case. You get a root b on top, and you get just b on the bottom. You're going to do that literally hundreds of times in the next couple weeks in most problems. So you can start just using shortcuts to do that. Okay, so now we found cosine and the reciprocal, which is secant. We found sine and its reciprocal, cosecant. Now we need to find tangent. Tangent is TOA. So tangent is 2 over root 21. Now, before I start to rationalize, I know I'm going to go ahead and flip that. Tangent and cotangent are reciprocals. So I'm going to take 2 over the square root of 21, and I'm going to find the reciprocal, which is the square root of 21 over 2, and that's done. Anytime the number on the bottom is a whole number, you are good to go. But 2 over root 21, I'm going to apply this shortcut, and I'm going to write 2 root 21 over 21, final answer. So all we did was number over number may be rationalized. So this is all leading us to the unit circle, whatever that means. Unit circle. So here we go to the unit circle. So we're going to take a circle and we're going to actually coordinatize it. So we're going to actually take this circle and we're going to take the x-axis, we're going to take the y-axis, we're going to center the circle at the origin. Okay, and then you're going to take any point. Now this is where we make the leap. Somehow we're going to relate trigonometry, which is triangles, to a unit circle, and here's how. You take any point on the circle. Okay, now I'm drawing it in the first quadrant. It could be in any quadrant. Here's where we make a huge leap. Okay, so xy on the unit circle. Unit circle literally means the radius of it is 1. So a unit circle is a radius 1 centimeter, 1 foot, 1 unit, whatever that unit of measurement is. And then here's the crucial part. Here's where we make the connection. Okay? When I plot point x, y, that means I'm going to go x spaces to the right and then up y spaces. So that means this right triangle in the coordinate plane, everything is on a grid. Everything is perpendicular. Everything is vertical and horizontal, right? So horizontal and vertical make 90 degrees. That's x, y. So we have x, y. So in this unit circle, we have x squared plus y squared equals 1 squared. Well, 1 squared is 1. So you're going to see this written over and over. In the unit circle, you can drop a point. We drop the point xy. And then you can build a right triangle. Now, once again, later on, you won't have to draw a right triangle, but we're about to make a connection. So I've just sketched what's called the unit circle, which is in the coordinate plane. I've put a point on the unit circle, and we see the relationship between x and y and 1. X squared plus y squared equals 1 squared. Okay, so now let's see, what does that have to do with all this other stuff we just talked about? Boom, here's what it is. So if I take, once again, any point on the unit circle, I'm going to make that sketch again. So any point on the unit circle, I'm going to call it xy again. And now it corresponds to t. T is my angle. Now we're using t. Sometimes it's theta, sometimes it's t. Lots of different ways to define that. But sine of t, sine is opposite over hypotenuse. Y over 1. So it's just y. And you'll hear me say this multiple times in the next several weeks. For any point on the unit circle, sine of that central angle will always be the y coordinate, because it's really y over 1, which is just y. Cosine of that angle t, cosine of t, is the adjacent leg x over the hypotenuse, which is 1. Well, x over 1 is just x. So you'll see over and over for the next several weeks that the cosine of a central angle in a unit circle correlates to the x coordinate. So sine of an angle is y, cosine of the angle is x. Tangent is always opposite, which is y, over the adjacent. So tangent is going to be y over x. Okay? And that goes back to tangent in calculus, big deal, is rise over run. It's slope. And this is where that comes from. So you're going to see that problem after problem after problem in calculus where that's the case. All right, so cotangent. Remember, cotangent is the reciprocal of tangent, so it's just x over y. Secant is the reciprocal of cosine, so it's just 1 over x. So if you want to find the reciprocal of a whole number, if it's a whole number, you just 1 over that. And then cosecant is 1 over y. Now, all of this depends on the fact that it is a unit circle. So this definition is very, it's clean, but it's only because we have a unit circle. All right, so note, you're going to see this over and over. Tangent, we said that tangent a minute ago was y over x, and y is sine, and x is cosine. So you're going to see that this is going to be a very useful piece of information pretty much the entire semester as long as we're doing trigonometry. Tangent is sine over cosine. Therefore, cotangent is cosine over sine. Okay, and we already defined this and this. So these two pieces of information are going to be very useful. Once again, cotangent's not easy to work with. So if you can replace cotangent of an angle with cosine over sine, that's going to be an easier number to work with sometimes in some contexts. Tangent, sometimes that's difficult to find. So if you can replace tangent with sine over cosine, that could be easier to work with, or the other way around. So we're going to use these two facts a good bit later on. All right, so let's do our one and only example with the new trig stuff. All right, so here's what we got. We have a point that is on the unit circle, -1/2. So just a reminder, on the unit circle, this point would be -1, 0. Here's the origin. This point would be 1, 0. I'm going to go -1/2 and then up. So here's the point, -1/2 √3 over 2. Now, why is that point on the unit circle? That's going to come into play later. I just want you to get used to, if I give you a point on the unit circle, that's all I need. Okay, so let's draw. Here's T. So T, here's what's crazy. Before, the angle inside the right triangle had to be between 0 and 90. Now T could be any number, so we're extending that definition. So sine of T, right, by definition is the y-coordinate. So sine of T is the y-coordinate, √3 over 2, and done. Cosine of T is the x-coordinate. Well, the x-coordinate of the point is -1/2. Straight definition. Sine of T is y, cosine of T is x. Now, what about tangent? Well, tangent of T is y over x. So let's plug those in. √3 over 2 all over -1 over 2. √3 over 2 over -1 over 2 is positive divided by a negative. The 2's divide out, and that leaves me the square root of 3 over 1, which is the square root of 3. Okay, so side note, I do want you guys to know this. These two numbers that you see here, so I'm just doing a side problem. Square root of 3 over 2 is very common. With unit circles, that is one of the most common values you're going to see. And when you divide that by 1/2, which is another very common value on the unit circle, this will always equal √3. Okay? So kind of a challenge to you is to take that and multiply it out and see what happens. Change division to multiplication and do all that stuff. Keep change, flip, and all that stuff from whenever you learned it. Grade school somewhere, maybe middle school. Okay, so we took √3 over 2 divided by -1/2, and we got -√3. Now, cotangent. Cotangent is the reciprocal. So now I need to take 1 over -√3. Well, I don't like that. I have to rationalize that. So I'm going to multiply top and bottom by the square root of 3. 1 times √3 is √3. -√3 times √3 is -3. So the final answer is... Okay, you're going to see these two numbers over and over. And it's not intuitive. The reciprocal of the square root of 3 happens to be the square root of 3 over 3. You're going to see that number over and over and over. Okay? Which takes us to our last, cosecant. I don't like cosecant, so I'm going back to sine. If sine is √3 over 2, then cosecant is 2 over √3. Not rationalized, so I rationalize it. And I'm left with 2 √3 over √3 times √3 is 3. Final answer. Believe it or not, For cosecant, that is a very common fraction. You're going to see that value a lot. Secant, I don't like secant, but I do like cosine. So I'm going to go back to cosine. Cosine was -1/2. So I have to take the reciprocal of -1/2, and that is -2/1. So just to be careful, common mistake, the reciprocal of any number is the same sign. You flip it, but you don't change the sign of it. So we flipped -1/2, and we got -2/1, which is -2. All right. Right at 30 minutes, not terrible for the very first, trigonometry stuff we've done. So guys, you have the video, you have the notes. It's a lot of information. Remember, we talked about this. I just dropped all the balls on the floor in PE class, and you're like, what's going on? And then in class, as we practice, we'll kind of group them together and start sorting out some of the thoughts. So, do you know the definitions? Yes. SOHCAHTOA, memorize that. Can you use it? Yes. Given a triangle, you can find those things. Find 6 values of the trig functions given a point on the unit circle. We'll practice more of that. But if you're given a point x, y, you can find the 6 trig functions. So we will do more with this in class. Guys, be safe, and I will see you soon.